Yeah, so in the last videos, we had a very clear discussion about, okay, so double linked list. I think in these, almost all the things we covered except reversing the list, right? So except reversing the list, so everything we have seen in the last videos. Now we need to implement this reverse function and let us see how we can able to reverse. Okay, so here for doing this reverse operation, I am not going for in detail implementation because already we have covered that. Just I will take, okay, so normal implementation, not recursive, normal implementation I am going to take. Observe carefully how it will be. So I think this program I am taking as it is. Oh, I think we are doing in Eclipse IDE, right? Let's open that. Yeah, so I think up to this we have covered nth node from the ending. Now I need to implement which function? Reverse function. So once if you apply reverse, that entire linked list should be reversed. For example, consider I want to print this list. So list dot, what is the function name that we have given? So traverse is the function, right? Yes. If you take, then the output is nothing but, so triple one, next node will become triple two, next node will become triple three, next node will become triple four, next node will become triple five, next node will become triple six, and last object will become null, right? Let us run up to this. Yes, we are saying like this. Now I need to reverse this. So what I am taking, double linked list, one is equal to, so I am going to take, so new double linked list. Okay, I think object is also not required. Directly you can call reverse function. So what reverse function is going to do? It is going to reverse all the content present in this linked list, so that your output should become triple six, followed by triple five, followed by triple four, followed by triple three, followed by triple two, and then triple one, and then last field is null. We have to implement in such a way that, so we know the code very well. So node, I am taking some temporary node which is nothing but initially null, and I am taking current node which will become head node, that is nothing but the starting node. So while your current node is not equal to null, so what instructions we are taking? I am taking a temporary node will become, so current node dot previous, I am taking, I am capturing the previous node, and your current node dot previous will become your current node dot next. Okay, and your current node dot next will become temporary node. Okay, then so your node current node will become, so current node dot previous. Like this we have to change the instructions. And finally, if your temp value is not equal to null, then your head will become temp dot previous. Anyway, I will show you how it is going to work. Listen carefully. Suppose consider I have a node like this. This is nothing but I have triple one. Okay, so next node will become triple two. So next node will become, since it is a double linked list, I am maintaining 2 pointers. and this node will become triple three. Like this I have. Yes, it is sufficient. This node will become null, and this node, next node is nothing but this one. This node previous is nothing but this one. This node next field is this one, and the previous node is this one, and it is null. And what is the name of this node? It is nothing but head. Okay, current node is equal to head. Now I am maintaining this node name as a current. Sir, is current node is not equal to null? Yes, it is not equal to null. Then temp will become current node previous. What is the current node previous? Null, right? That will become temp. Listen carefully. Then current node previous. Current node previous will become current node next. Okay. So after this, what output we are expecting? So triple three, like this we have, and then triple two. Okay, like this we are going to get. Just for your understanding purpose I am taking, and this is nothing but triple one. So what will happen? These links we are going to remove. How we are removing? Okay, temp will become current node previous. This is the current node, its previous field is null. That's why your temp will become null. And current node previous, previously it was null. Now I am making this one as a current node next. What is the current node next? Triple two, right? So that will become previous to triple one. So previous to triple one will become current node next field, like this. Then current node next field will become temp. Current node next field will become temp. That means null. Like this we are maintaining. Then current node will become current node previous. What is the current node previous now? Already we have attached, right? Triple. This will become current. Now, is it not equal to null? Yes, it is not equal to null. Now see what will happen. Temp will become current node previous. Temp will become current node previous. In this example, current node previous will become this one. So this is nothing but a temp. Listen my words. Now, current node previous, this is the current node, its previous will become current node next. What is the current? Triple two. What is the next to this one? Triple three. Now, current node previous will become this one. Then, current node next will become temp. This is the current, right? Next field is what? So, this is the current node, right? Next field is what? Temp. So, triple two next field will become triple one. Perfect. Now, current node is equal to current node previous. Current node previous is nothing but triple three. This will become current. Again, is it not equal to null? Yes, it is not equal to null. Then temp will become current node previous, which is nothing but this one. Now, what will happen? Current node previous will become current node next. Current node previous means this previous will become current node next. That is nothing but null. Okay. Then current node next field will become temp. That is nothing but triple. And the current node will become current node previous. What is the current node previous? Already we have changed that. So it will become null. So your current node is pointing to null. So is current node is not equal to null? Yes, it is null. It will come out from this loop. If temp is not equal to null, temp is there. Okay, if temp is null means what? We have only one node is there. That will become reverse. So that's why I am not doing that operation. If temp is not equal to null, your head will become temp tends to previous. Okay, what is a temp tends to previous here? Okay, your temp tends to previous something. Temp will become current node previous. So head will become temp tends to previous. This node previous field is nothing but we have changed, right? That is nothing but triple three, which will become head node, which will become head node. Okay, this is nothing but how we can able to implement. Okay, so I think you people got very clear clarity about how you can able to do this reverse operation. Sir, don't feel that here temp you have taken, its previous field is nothing but this one. Don't assume that these links we have breaked, that one only we have understand here. So I have given the links here in blue color, means what? These links are broken and node names as it is available, only that links I have changed. Okay, for getting better clarity. Okay, can you please confirm, is this a reverse function, how it is going to work? Is it clear for you people, guys? Please respond. Right, but I need to check, right, whether really is it working or not. We have to cross check really whether it is working or not. We have to cross check. Let me run the code. Sir, are you getting the reverse? Yes, perfectly. All the elements got reversed. This is nothing but how we can implement double linked list program. Okay, I think in the double linked list, what are the operations that we can able to perform? Everything we have finished, sir. Okay, so with this, double linked list concept got completed. So I think with this, you people got a clarity how we can work with connections, how to break that links, how to attach that links. Everything is clear for you. Can you please confirm, is it clear up to this? Please confirm, sir. Right, sir. So but how many operations we have performed here? Okay, how many operations I have performed in this single linked list and double linked list? Those many operations I am not going to do in circular single linked list or circular double linked list. Only few operations I will perform. Okay, let us go with the circular single linked list. Sir, what is mean by this circular single linked list? Very simple. Here the nodes are attached in a circular manner. Means if you take first node here, one, its next field is nothing but this one. So its next field is nothing but this one. So its next field is nothing but this one. What about this next field? It is attaching to the beginning. That is nothing but what we have. Sir, it is more confusing. Yes, that's why I am covering only limited program. I mean, limited operations I am going to cover on this. Rest of the things you can think and you can implement. Sir, how you can able to point out head node and tail node? Just I will concentrate only on tail. That is nothing but I will concentrate on this tail last node. So if I want to get a head node, what is the head node? Tail tends to next will become head node or not. Like this I am going to maintain. And here compulsory you have to depend on always size. Okay, so this size tail, by using these two pointers only, we are going to run the entire show. So directly I'm taking the program so that you people can understand. Okay, so which program I'm going to take? One second. Yeah, so here in 7 p.m. So we have double linked list. So here I'm going to create a new class with the name. So circular single linked list. TSL, circular single linked list. Like this I'm creating. Okay, now see how I am going to implement. Sir, what are the requirements? We need node tail. Just now I explained, right? Node tail. And integer, what will be the size? Size will become 0. So your size will become 0. 0 elements are there. Then I need to take that node or not? Yes, compulsory. You have to take a child class of a node I am taking. And in these, what fields we need to take? As usual, we have data field, which is nothing but a value, and we are going to maintain next field, which is pointing to the next node. And I am going to create a constructor with a value field and a node next field. So this dot value will become value, and this dot next field will become next. Like this I am going to assign. So constructor is okay, class node is okay. So my single linked list structure skeleton template is ready for us. Now you can create a direct object for circular single linked list is equal to list is equal to, so new circular single linked list like this I'm creating. Sir, what are the operations that we are going to perform? So first operation is nothing but something like print or traverse. I need to print the elements, right? That is nothing but my main requirement. So first I am going to take void print. Sir, what is this operation? By mistake, if your size is equal to 0, then what is the meaning? We don't have any elements, right? Then circular single linked list is empty. We don't have any elements and simply written. Otherwise, node, listen carefully. So we are taking temp is equal to, generally temp is equal to which node we are taking? Head node, right? But I told, right, how can I able to point out a head node? Tail tends to next, while temp is equal to tail tends to next. So until your temp is not equal to, don't take null because it is a circular fashion. It keep on running. So how you can able to take until your temp is not equal to, so tail, until your temp is not equal to tail, then system dot out dot println of, so you have to print a temp dot value, so followed by that link I'm going to take. That's all right. And a temp will become temp dot next. Sir, finally we need to print one value. So why we need to print that value, I will explain. Temp dot value we have to print at the end. Okay, 1 second. Now sir, I will take one example for you to understand. Listen carefully. Suppose consider I have uh, a single circular linked list is there. This is nothing but the first node. Okay, and this is nothing but the second node. Okay, and this is nothing but the third node, and this one is nothing but a fourth. Like this I have how many nodes are there, sir? Four nodes are there. We know its next field is this one, its next field is this one, its next field is this one. Unfortunately, its next field is also this one, and we have a pointer towards this node which is nothing but a tail. And consider the data, any data you can take. Now sir, what I am doing is size is equal to 0. No. Okay, then temp is equal to tail dot next. Tail next field is what? This one, right? I am taking this one as a temp node. Okay, now see, listen carefully. Is a temp is not equal to tail? Yes, it is not equal to tail. Then system dot out dot println of temp tends to value 1. Then temp will become temp tends to next. Now onwards a temp will become this one. Is it not equal to tail? Yes, print the value. Next your temp will become temp tends to next. Is it not equal to tail? Yes, then it will become 3. Then your temp will become this one. Sir, is it equal, is it not equal to tail? No, it is equal to tail. It will come to from this. Finally we are printing temp tends to value. That's all. Don't print null after this because anyway it is pointing to the beginning. Okay, anyway it is pointing to the beginning. That's why just I'm not going to print that. Okay, so I hope how to use this print function for circular single linked list, it is very clear for you. Right friends, please confirm if you are okay with this. I will go with addition of elements. If you are okay with this, I will go with addition of elements. Is it clear, friends? Please confirm everyone. Okay, right. Now, anyway, I can't execute, right? Because we don't have these many elements. But if you want to just let me run up to this, I'm trying to print anyway, initially we don't have any elements. The output what we are getting is circular single linked list is empty. Boss, can I add the elements? Yes. I will explain the addition in both places. What is the first one? Add head I am taking. Okay, add head means what? Inserting at first. Here first last you can't give guarantee because it is in a circular fashion. That's why I will represent add head. Add head means first node. So integer I am taking value. This value we have to add. Listen carefully. Node temp is equal to, I am creating a new node with this particular value, and the next field is null. Like this I created. Suppose if your size is equal to 0. If size is equal to 0 means what? We don't have any elements. Then your tail will become temp. Okay, your tail will become temp. And then temp dot next will become which one? Temp only. Suppose if already some are there, then what we have to do? So your temp dot next will become tail dot next. Okay, so your temp dot next will become tail dot next, and the tail dot next will become temp. That's all. Very simple operation. And after doing this, what we have to do? Anyway, whether you have executed if or else, immediately size plus plus. First, I will explain how you can able to add at head. Okay, listen carefully. Consider initially we don't have any elements. I want to insert a triple one as a head. Sir, is it otherwise? Let me take triple. Is it available? No. A new node will be created. Okay. So a new node will be created. Since size is equal to 0, your tail will become this node. Actually, the name of this node is nothing but a temp. And this one will become what, sir? Tail node. This one will become what? A tail node. What is its value? It is nothing but a 344. And what about next field? It is pointing to the same temp. That means this node only. Like this we have. So when you are inserting very first, sir, already one node is there. Suppose consider now already this 344 is there with us. Okay. Now, so consider this is nothing but the link what I have, and this one will become which node, sir? Tail node. Now what we have to do? Add first, right? That's add head, right? That's why here we are going to get a new node. Let us consider the content is nothing but 333. And what is the name of this node? It will become temp. Right. Sir, is size is equal to 0? No, one node is there. Then temp tends to next will become tail tends to next. What is the tail tends to next? Unfortunately, it is tail only. Now we are deleting this, and we are making temp tends to next will become tail tends to next. Then tail tends to next will become temp. That's all right. Very simple operation. Suppose consider I want to insert one more item. Already we have two nodes are there. This is nothing but a 344 we have. Okay, and this will become your tail node. So and we have one more node is there with name 333. So this link is pointing to this one, and this link is pointing to this one. So here I need to create a new node. Let us consider its data is triple one. So this is null initially. And what is its name, sir? It is the temporary. Sir, is the size is equal to 0? No. Temp tends to next. Sir, temp tends to next. We are changing this temp tends to next to. Sir, which one? Tail tends to next. What is the tail one? This one. Its next field is nothing but this one, right? So this node, I am pointing this node. So its next field will become this. So that by default, this one is gone. Now, so tail tends to next will become temp. Like this we are going to assign. See here our main concept is we are fixing that tail pointer. By using that only we are doing almost all the operations. Okay, I think how to add the element at the beginning is clear, but I need to execute, right, to get a proof. So first, which one we have added? So add head of, let me add 3. Then list dot add head of, I have added 3. So after that list dot add head of, so we have added 3. So my expected output is 311 followed by 333 followed by 344. I am expecting. Let us run the code. Is it working? Yes, triple one, triple three, triple four. Sir, there is a small issue. I think at the printing I have used LN. That is the problem here. Okay. Otherwise, it is going to get it in a single line. Anyway, null won't be there because we should not keep. Why? Because this triple four next field is nothing but a triple one. Okay. That's why I am not going to change. So I think this concept is clear for you. Can you please confirm how to add at the node? Is it clear for everyone? Please confirm. Is it clear for everyone? Circular single linked list, add first. Sorry, add head method. Is it clear? Clear? Please confirm everyone. Right. Now I need to talk about so void add tail. At the end, I need to add. Okay, how you are going to add at the ending? Sir, it is also something like same operation, but a bit tricky code we need to write. So node, I'm creating a temporary node with so the data whatever you have given, and then next field is anyway null. Suppose if your size is equal to 0, if you don't have any elements, then as usual your tail will become that temp node, and your temp dot next. Okay, your temp dot next will become temp playing. Sir, I have already certain content is there. Then so temp tends to next. Your new field next will become tail tends to next. Tail tends to next. That means first node. Then your tail tends to next will become temp, and your tail will become temp. That's all. Anyway, after doing this, we have to increment the size. Now I will execute this code. First, I will explain with the help of a small diagram. Observe carefully. Suppose consider I have already some content is there. Like let us take this is triple one, and the next field is pointing to triple two. Okay. So next field is pointing to triple three. Okay, like this I have. So next node is nothing but okay, let it be triple four also we will take. Like this we have, and the next field is nothing but this one. What is the name of this one? We know very well, it will become tail. Now sir, I'm creating a new node here. I'm creating a new node here. What is the name of this node? This node will become temporary node. Next field is null, and the data is nothing but triple five. Like this we have. One second. Now so here is size is equal to 0. No. Else so temp tends to next will become tail tends to next. Sir, temp tends to next is null, right? Now it will become what? Tail tends to next. Tail tends to next is nothing but a triple one. So temp tends to next will become what? Tail tends to next. Now okay, tail tends to next will become temp. This is the tail, right? Its next field is belongs to temp. Then your tail will become temp. So this will become tail only. So by default, this one is going to be gone. And which links will be deleted? This link will be gone. Okay, like this we have. So, but I need to execute this code, right? To check whether really it is working or not, we need to execute. So already some nodes are there. So I will add list dot so add tail of I will take so triple five, and list dot add tail of I need to take a triple nine. So where the items are going to be added, here it will add triple five, and here it is going to add triple nine. If you execute the output, what we are getting is like this. Okay, sir, clear up to this? Can you please confirm? Is the adding of objects, adding at ending, Is it clear for everyone? Please confirm. Clear? Right. Now I need to go for the next one. Okay, I need to go for next one. Can I add at a specific position? Yes. Happily, we can able to add at a position also. So add POS. Here we are going to give the value as well as the position. First I will give position and then later I will give value because that is the correct format, right? Now we need to implement. Sir, how we are going to implement anyway? The creation previously size plus plus. Oh, right. So node temp will become, so new node of, we are going to take the value and your next field will become null. Suppose if your size is equal to 0. So what will happen? That is our main concept. Otherwise, what we are going to do? Anyway, size plus plus. This is the template, right? If a size is equal to 0, your tail will become, so new node. Okay, new node or temp, anything we can take. So better every time we are using new node only, right? Let me habituate. So tail node will become new node. Okay, then your new node tends to next field will become new node only, like this. Suppose if you have elements already, okay, if you have elements already, then if position is equal to 0, that means I want to insert at 0th position, then node temp is equal to, so tail dot next, tail dot next. Okay, so tail dot next, that means it will comes under beginning, then your new node is there, right? Your new node next field will become temp. Okay, so your tail tends to next will become new node. Don't worry, I will explain this code. Like this we have. So then immediately I need to come out from this, I will use return. So if position is not equal to 0, what we are doing? I need some temporary node which will always pointing to tail dot next, and I need to identify the position, right? That's why I is equal to 0. So while your temp dot next is not equal to tail, at the same time I less than position minus 1. Then I am moving temp is equal to temp dot next and as usual I plus plus. So if this while loop fails, then what is the meaning? We came to the perfect position. Then new node dot next will become, so temp dot next, and temp dot next will become, okay, new node. That's all. This is the code what we have. Anyway, I will write and I will explain. Listen carefully. Suppose two cases are there. What is the first case here is, this is nothing but the node I have. This is nothing but the nodes I have. Okay. Consider this one is 1, 2, 3. Next field is nothing but this one. Next field is nothing but this one. This next field we know very well. It is this one. And this one will become tail. Now I want to insert the node called 9 in 0th position. So how you can able to insert at 0th position? Very simple. So we have to create a new node here. Okay, we have to create a new node here. This will become new. Now temp is equal to tail dot next. Tail dot next will become temp. This is nothing but a temp. Then observe carefully. I am breaking the links. Temp will become tail tends to next. New node tends to next will become temp. New node tends to next will become temp. Okay, tail tends to next will become new node. Tail tends to, so next will become your new node. Okay, so like this I am going to break, so that what will happen? By default this link is gone, right? This is nothing but one way what we have. Suppose if I have elements already, something like 1 I have, okay, so next and after that 2 I have, so next and after that 4 I have, so I need to add 9 here. Okay, I need to add 9 here. This one will become new node, and this one is nothing but a tail node, and the next field is nothing but this one, its next field is nothing but this one, its next field is nothing but this one. Okay, your temp will become tail tends to next, tail tends to next, this is nothing but my, so temp node I is equal to 0. Sir, which position you need to insert? Your position will become 0 1 2 in second position. So temp tends to next is not equal to null, temp tends to next is not equal to tail. Okay, and I less than position 0 less than, so 2 minus 1 means 1 condition, then your temp will become temp tends to next. Then I plus plus your I value will become 1, and the temp tends to next is not equal to tail. Oh, here temp tends to next is equal to tail. Suppose consider we have another node is there, so that you people get clarity. So I have another is there like this. Now, sir, temp tends to next is not equal to tail. Yes, temp tends to next is not equal to tail, but I less than position, 1 less than 1 condition is not satisfied. So means here we have to insert that. Now what will happen? Your temp will become, sorry, it is going to fail. New node tends to next will become temp tends to next. So new node tends to next will become temp tends to next. Now observe carefully. New node tends to next will become temp tends to next. That is this one. And temp tends to next will become new node. Temp tends to next will become new node. Like we are going to break this link. That's all right. I will execute this code up to this so that we can cross check whether it is working properly or not. Okay. Second, another batch is there. Just I will give the message. Right. So I will add tail. So I'm going to use add tail method. First one, and then two, and then three, and then four. Like this I have. So what elements are there? So I have 1 followed by 2, so followed by 3, so followed by 4. Like this I have. Really, is it happening or not? Yes, 1 2 3 4. Like this I have. Excellent. Now, sir, I need to add at a position. So list dot add position of, in 0th position I want to add 9. So where 9 is going to be added here, right? Let me cross check. Is it added or not? Yes. I want to add at a first position. That means 9 we are going to get here. Is it correct? Perfect. Sir, I want to add at a 2. That means where we have to get 9. So here we have to get 9. Is it correct? Perfect. Sir, I want to add at third position. Where it has to be added here. Let me cross check. Perfect. Sir, I want to add at fourth position. Okay, let us cross check. I think it is not going to be affected. It is going to add only at this position. Okay, so if you want to, you can check the range also, right? That kind of program also I have explained already. Okay, so I think how you can able to add the particular element at a given position, it is very clear for you people, guys, right? Can you please confirm? Do you have any doubts up to this, friends? Please confirm. Is it clear? Yes, everyone, please respond. Right, sir. So anyway, remaining things we will continue tomorrow. Okay, anyway, remaining things we will continue tomorrow. There I will talk in detail about rest of the methods. Okay, this is nothing but circular linker list. So I will upload this running notes within a few minutes. Max tomorrow we will wind up this single linker list and sorry, circular single linker list and circular double linker list. Linker list concept will be finished tomorrow. Okay, right, sir. So after completion of that, maybe we will start a stack or hash table, something like that. We will start. Okay, right, sir. Thank you. See you tomorrow. Yeah, good night.